Anyone have any questions from 12.1, 12.2, 12.3, 12.4? Most of it is an exact answer, so it's kind of nice. The odds, the answers in the back of the book, so you can see if you got your answer correct or not. And it's somewhat frustrating if you didn't, because you did a lot of calculations to get there. So more than likely it's the wrong button. If you guys are like, yeah, we know. You're just hitting a wrong button in your calculator. So on the exam, there's only going to be one standard deviation problem. There might be a question asked how, write a paragraph or write a sentence on how to calculate standard deviation. There will be one just to see if you can do it. And it might be worth your time to kind of do it twice in your calculator to make sure you get the same answer, if you have that time. All right, today we're going to continue on with 12.5, which is measure of position within a data set. 12.6 will be comparing data sets and looking at the position within one data set and comparing it to a position in another data set. So we're going to use a lot of the same ideas from 12.5, but we're going to apply it in 12.6 quite a bit differently. 12.5, we're only looking at one data set at a time. And we're going to compute the percentile rate for the data value. So given any number, a lot of times it's represented as scores. Like here's a list of how people scored on the first exam. What is your percentile rank? So you would take your test score and you would find how many people were below you, and we're gonna be able to calculate that. And so you can say my percentile is 75%, meaning you scored at 75% of the class scored at or below your score. Your percentile is 25%, means 25% of the class scored at your score or below it. So you can kind of see where you fall in the class. And then another thing that's common with this is rank. I'm ranked number 1, I'm ranked number 2, I'm ranked number 3. That's probably what you're a little bit more familiar with. If you didn't graduate high school too long ago, you had class rank. You also have a percentile rank. And then the last thing we're going to do is compute quartiles. So there's a first quartile, second quartile, which is really just the median, and the third quartile. And that's used a lot of time in box and whisker plots. So anytime you take a standardized test and you get the data back, they'll have a box and whisker plot and kind of show you where you fall, and then also give you a ranking and a percentile. All that's tied together. So the first thing we're going to talk about is percentile. A percentile or percentile rank of data values indicates the percent of data values in a set that are below a particular value, right? So 75 percentile means 75% of the class is below that value, or 75% of the people that took the test is below that value. So that would be a good 50 percentile means you fall right in the middle. 50% is below that. Here's our first example we're going to look at. So suppose we have 10 scores. So we have 10 people that took this test. And we want to know what is the percentile rank for the test that scored a 77. So let's say you took the test and you scored a 77. So this is your score. And we want to write that as a percentile rank. So the first thing you want to do is you want to arrange them from smallest to largest. So this is kind of where you fall. So first step is to write them in order. The second step is to find the number of data values below 77. There are 4 values below 77. You take 4 divided by how many scores we have, and that would give us a 40%. So a test score of 77 is equivalent to the 40th percentile. Right? You can never be the 100th percentile. Right? If I was this score here, 98, I'd have 9 scores below me. I would be in the 90th percentile, right? If I have 100 scores and I scored the highest, I'd be in the 99th percentile. You're never at the 100th percentile, if that makes sense, right? You always count how many scores are below your score, divide by how many total scores, multiply that by 100 if you want percentile. Your calculator is going to give it to you as a decimal. You're going to just convert it by multiplying by 100. Move the decimal 2 places. Make sense? So let's look at this one. We can go both ways. The number of words in each of the last 10 presidential inaugural addresses listed below. Find the length that corresponds to the 30th percentile. So we're going to go backwards. We want to find which one represents the 30th percentile, right? So what number would represent the 30th percentile? The fourth one, right? The third one, because we have to have 3 below it, right? So it would be the fourth one. So since there's 10 here, it's relatively easy to find it. It's going to be the fourth one because we want the 30th percentile. If we wanted the 40th percentile, we pick the fifth one. The 50th percentile, and so forth. So it's pretty straightforward when there's 10 of them, right?
So what if there's 12?
So what we solve for is x over n times 100 equals our percentile. So if we know our percentile, we solve for x. If we know x, we solve for a percentile. And on the percentile, not all percentiles are possible. Like there isn't a 15th percentile here because that would be between 10 percentile and 20 percentile. This, you can think this is the 0th percentile, the first. Yeah, the first percentile, the second percentile, the third percentile. So this would be the 10th, 20th, 30th, 40th, 50th, 60th, 70th, 80th, 90th. So it wouldn't make sense in this problem to say what is the 45th percentile because there's only really 10 numbers. Question.
What if you're tied with someone? Are you both the percentile, or do you count that person?
That's a good question. At or below. With small amount of data points, it can range, vary. You know, it could be the 20th percentile and the 30th percentile. Most of the time, you have so much data points, it doesn't really matter. We had 100 data points, then we're going to have first percentile, second percentile, third percentile. So it makes sense that what is the 47th percentile? And there could be 2 numbers, so you just list them twice, so it would represent 2 percentiles. So
I guess we'll never have to do that though.
Yeah, I mean, it's going to make sense for what you're going to be asked for.
Okay.
Yeah, if there are more than 1 scores, if say this score is the exact same as this score, it would represent the 20th and 30th percentile. So this score would represent the 20th percentile, this one would represent the 30th percentile. A lot of times the data is so large they don't repeat the numbers. So they would just divide by the n and you would have the same percentile.
Well, I was just thinking test score in the class.
Yeah, kind of where you fall, yeah.
Stuff like that could repeat. But
Here's an example of like an application to this. 2 students are competing for 1 remaining spot in law school class. Miguel ranked 51st in his graduating class of 1700, while Dustin ranked 27th in class of 540. Which student's position was higher in his class? Percentile range. So we have to do some calculation because it's not that clear. So we want to find Miguel's percentile and Dustin's percentile. So to find Miguel's percentile ranking, we got to find how many people were below him. So if he was ranked 51st, so we take the number of students in his class minus 51. 51 people are above him. Well, he is a 51. So him and 51 people are above him. So that means 1,649 people are below him. So to find that ranking, we would take the number of people below him divided by the number of people in the class. And that would give us 97%. To find Dustin's, we would do the same thing with him. He's ranked 27th. So there's 513 people below him. We do the calculation and we get 95%. So while both are excellent students, Miguel's ranking is higher, even though if you look at where he falls in his class, 51 versus Dustin being 27th, it's all relative to how many students are in the overall class. So being 51 out of 1,700 is a lot bigger deal than being 27 out of 540. So this is a good application of percentile rate within comparing two data sets. Any questions on that? So what we're doing is basically we're finding the percentile rank for each one of these students given their individual data points. And at the end, I think we're going to have time to be able to do some more examples like this one, where there's not maybe 10 data points, maybe there's 12 data points, and you have to find what score is a certain percentile rank. With 10, it's pretty straightforward. You can either be 0, 10, 20, 30, 40, 50, 60, 70, 80, or 90. And then you just count those numbers. So a lot of times the data is divided up into quartiles. Quartile divides the data into quarters. There's really only 3 quartiles. The first quartile, the second quartile, and the third quartile. Because if I have a line and I cut it into 3 parts, I get 4 lines. If I cut it 3 times, I get 4 lines. The second quartile is the same as the median. So if I have, let's say if I had a score from 100 to 0, then the median is going to represent Q2. The first quartile, Q1, is going to be the median of the lower half, and the third quartile is the median of the upper half. Some textbooks actually switch Q1 and Q3. It doesn't really matter, but it's the median is the middle value, right? So what we're doing is we're kind of chopping up these data points into evenly distributed point values. Now this might not be 25 units long. This might not be 25 units long, but there's going to be the same number of data points in this region as in this region. And that's what median does. It cuts the number of data points in half. So if I have a lot of really high scores, I can have a high median. If I don't have very many low scores, these numbers kind of can be shifted. So we use the symbols Q1, Q2, and Q3 for the first, second, and third quartiles respectively.
So how are you going to do it on the test? Are you going to do Q1 as the first half?
It kind of depends on the data, what makes sense. If we're looking at test scores, makes sense for Q1, Q2, Q3. But if we're looking at like time, like if I'm timing for a race, Q1, Q2, Q3, it's kind of the opposite of what we think low score is. Because if you're running a race, the longer you run, it's kind of like the lower your score because your time is longer. That's why Q1 and Q2 is or Q1 and Q3 are kind of switched in different books. It really depends on your data and what makes sense for the data. I'll be flexible on it. Q1, Q2, and Q3. The reason why in this case, they list Q1 first, it's the lower end, Q2 is the median, and Q3 is the upper end. So generally, Q3 will be larger than Q1.
All right, we need to write that down because it's that printed, so
What, the,
examples for.
oh yes, you need to write, yeah, it got cut off the bottom. So you need to write these numbers down and find Q1, Q2, and Q3.
You forgot.
Oops, I did forgot 24. 24, 35, 36, 32. So this is just writing them in order. So I always like to find Q2 first, because that's just the median. So what is Q2? It's going to be in between 21 and 24. There are 8 data points. So I would take 8 plus 1 over 2, which would be 4.5. So it's in between the fourth and the fifth. One getting that would be 45 over 2, which would give me 22.5. So that's Q2. What would be Q1?
Between 35, 36.
Good. So it would be in between these two, which would be 35.5. Q1. What would be Q3? The first quartile is the median of the lower half. The first quartile. It doesn't really matter. Q1 and Q3, if you switch them, that's fine. Like I said, it makes sense with the data points depending on what they mean. Here they don't. They mean aircraft stolen during the recent 8-year period. It could be Q3, that's fine. And I believe, let's see, and your book even calls it Q3. So Q1, Q2, Q3. You can just stick with that order. So the median of the data value is less than Q2. Q2 is always your median.
Okay. 20 plus 14 divided by.
Oh, sorry. These are the lower ones. So this is right from what? This is Q3. This is Q3. This is Q2. Or Q1, sorry. So 14 plus 20 over 2, which would be 34 over 2, which would be 17.
So Q1 17.
Q1 is 17. That's the lower half. 22.5 is Q2. And the upper half median is 35.5. Really what this comes from, where this becomes useful, is a box and whisker plot, which your book doesn't stress. Then they have, really the median's not really listed. 50% of the data points fall within this box. 50% of the data points fall without this box, with outliers in a sense. And you can see where the median here Now, this is not to scale, but you could put it to scale and it might look a little different. If you put units on here, then it might be shifted a little differently. Question?
Okay, so on the Q3, if those weren't like, right, if they weren't consecutive numbers,
Yeah.
you would do it the same as the others?
Yeah.
Okay,
Even though they are consecutive numbers, you can do it the same as the other. You just get 35.5.
yeah,
It's just easier to see halfway in between.
yeah. But if they weren't, and
Yeah.
you would do it the same as the others? Right?
Yes.
Okay.
Yes. So if you go to here's just a kind of a picture of, this is Wikipedia, but the definition of quartiles. Here's an example of kind of how they fall. This is a normal distribution, so it's going to be somewhat uniform. This is going to tie into this, which is what we're going to talk about on Friday. And this is the normal distribution curve, and we'll have to memorize some numbers. And then we'll talk about two ranges of data points. What percent of the population scored between a 70 and an 80? So you have to convert that to normal distribution curve, look up your table, and then correspond. If there was 100 people that took the test, or if there was 1,000 people that took the test, if 80% scored within this range, you would take 80% of however many took the test. So that's kind of what we're leading up to. We did this, we found the first quartile, the second quartile, and the third quartile. Let's go to your homework, 128. On 12.5, 5 through 21 on. So you do box and whisker plots in this section. Do they give you?
Did you say it was 5 through 25?
5 through 21 odd.
Okay.
So yeah, the useful application is the box plot, and it's a way to easily identify data points that are outliers. The process of drawing a box plot is labeling the smallest value and the largest value, and then putting Q1, Q2, and Q3 on the number line. Put a box around Q1 and Q3 and a line at Q2. And this gives you a way to visualize the data. Like I said, 25% of the data points are here, 25% are here, 25 here, and 25% are out here. So it's a really good way to kind of see outliers. But this 74.1 is an outlier. 25% of the data points fall within this range. It's a pretty large range. 25% fall here. So if we were looking at interpreting this, we could get information from maybe the outliers. This low score is bringing down the median value, or not the median, is bringing down the mean value, the average. Because we were looking, this is much higher up here. So if I got rid of this outlier, my mean will go up. So to kind of calculate an outlier, any data point that is more than this distance away. So if you look at the interquartile range, so the range in this case of Q1 minus Q3, multiply it by 1.5, any point outside of that is going to be considered an outlier.
Any point outside of the box.
Any point outside of the range times 1.5. If you take the difference in Q3 minus Q1, or Q1 minus Q3,
Okay.
you take that difference, multiply it by 1.5, any data point that's outside of the distance away from that box, so above it, right, if I take whatever this range is times 1.5 plus this, whatever this range is times 1.5 minus this, any point that lies outside of that is going to be an outlier. Some box and whisker plots even go a little bit further, and they'll show you exactly where the dots are. If there was 8 dots, each box are going to have the same amount of dots. You might have seen one on some kind of standardized test if you take Missouri assessment, or if your students get them. I don't know, they send them home. I think in 4th grade they do an assessment, and they'll give you kind of where your student lies in the box and whisker plot. And they might even do one for the class. So if you have a class, a group of students that are, always kind of outside of here, then they might look at the teacher. And Missouri, I think, is trying to do performance-based pay for teachers in the way, if you're scoring these outliers, if you're above it, then you might get some kind of bonus incentive. If you're below it, you might, have some kind of remediation punishment where you have to go take some classes or something. But there's a lot of data here. So this is where they can subtract or add that outlier amount to see if it's an outlier or not. Here's an example of a box and whisker plot, and you can see the difference here in the first quartile and the 3rd quartile is pretty large. So we're not going to probably have any outliers here. It helps when you draw it to scale, kind of see. But again, half the scores were above this, and half were below. So the below scores covers a much larger range than the above scores. The width of the box tells us if the data is pretty spread out. And the fact that the median falls so close to the upper end of the box means that the higher data values are clustered closer together. Right? There are the same number of data points in this range as there are in this range. So if I have to fit the same number of points in this box and in this box, these points have to be closer together than these points. And the fact that this box is bigger than this box tells you that the wide range of the spread is in this range. So it's just kind of a way to visualize the data there, but it's all on medians, the middle. So nothing to do with like the average there. So that's kind of the box and whisker plot. We don't do a lot of it. And here, number 7, you have 20 students. So you want to find the percentile rank of a score 32, 44, 36, 27, 49. So here it's only going to really make sense to be the 5 percentile, 10 percentile, 15 percentile, all the way up to 95th percentile, because there's only 20 scores. So if you rank them from smallest to largest, find how many of them are below 32, divide that number by 20, multiply by 100, and you get the percentile for the score of 32. Find the percentile rank for score of 44, you do the same thing. How many scores were below 44? Divide by 20 times 100, and that would give you that percentile rank. But it should only be the 5th percentile, the 10th percentile, the 20th percentile, the 25th percentile, because there's only 20 scores.
So you figure out how many are below the score of like the first one, 32.
Yes.
And then you divide that by 20,
Yes.
and then you multiply it by 100.
Yes. And that would just give you a percent.
And that's what we're wanting here, right?
Yes. But if you get like 0.45, then it's 45%. So multiplying it by 100 just moves a decimal 2 places to give you the percentile, to give you the percent. If I say 0.37, that's the same as saying 37%. That's like if I was saying 37 cents, that's the same thing as saying $0.37.
Right.
So it wants you to list it as a percentile though, so you want to get rid of the decimal. Number 9. In a class of 500, this person's rank was 125th. Find the percentile rank. So here we take 500 minus 125. That would tell us how many students are below that student. Divide by 500 times 100. Number 11. This person finished 43rd out of 200. Find the percentile rank. The same approach as number 9.
200 minus 43 divided by 200 times 100.
Yep.
Okay.
13. This one is where we're going backwards. This one we know her percentile. We want to find her rank, or we want to find how many students scored below her, right? So we're going to work kind of backwards here. We know the percentile. We don't know how many students scored below her. Students lower divided by n times 100 gives me my percentile, right? So now we can work backwards. We don't know how many students scored lower than her, so we're going to call that x. So x over 50 times 100 equals 0.20. Or we can get rid of the times 100 and then says equals 20%. How could I solve for x? Yeah, multiply by 20%, right? But I either hit 20% in my calculator or change that to a decimal. You cannot enter 20 in your calculator times 50 and expect to get x. You have to take 20%. So x over 50 equals 0.20. I multiply both sides by 50. X is 10. So that's how many students scored lower than she did. So her rank in this case would be 11. No, it's backwards because it would be 10 would be, so you're ranked first if you were the 50th score, right? You're ranked second if you were 49th, 48, and so forth, right? So she would be ranked 40, not 40, 39th. 39th. She would be ranked, her rank would be 39 because 10 people will be below her. See, it's a little bit backwards what you would think. If you came in first place, does this make sense? 50 students in the class. If you got the top score, right? So 50 all the way down to 1. If I rank these, this student corresponds to rank number 1. This is ranked first in his class. If you got the next highest score, you're ranked second. Let's see.
So if you got 50 on the 50, you're number 1. Is that what you're trying to say?
Yes, if you come in first, you're ranked number 1. That's why percentile rank and rank kind of are backwards of each other, because percentile rank is how many people are below you. 20% of the class is below this person. She's ranked 20th. Let's see, let me go back.
Percentile is below.
She scored in the 20th percentile.
Okay.
So she would be ranked 39. It's a little backwards than what you would expect, because if you're ranked first, you're in the 99th percentile, or 90th, depending on how many data points you have. If you only have 10 data points, you'd be in the 90th percentile, because 9 people are below you.
38 students are below.
Her, 10 students are below her.
Oh, can we talk about running races? Because I've done that.
Okay, so if you run the race, if you have the smallest time,
Yeah.
you're ranked first. You get first place,
Right.
right? So all your time beat 99% of the other people.
Right. You're first.
Yeah, you're first, so your percentile would be 99%.
99% are below.
Because
me, or
you're
still-
better than 99% of the people that run the race.
Man, I feel so backwards right now.
It is. It is a little backwards because a lot of times you think, oh, I want to be ranked a high number in my class or a low number in my class. I'm first, I'm second, I'm third. So it's positive. But it's backwards with percentile. Percentile, you want a high number because that means you're better than 98% of the class or 99% of the class versus your ranking.
So when your kids are in the 75th percentile for
Mhm.
height.
Yes, that means they are taller than 75% of the
Yeah.
students around their group.
Right. Only a quarter would be small or bigger than this.
Yes.
Bigger.
See, and that's another thing. You have to be careful with the data points because in height, we think of 75 percentile means that they're taller, right? Only 25% of the people in their age group are taller than them. But if we were talking about like running races, you would think of it all as opposite. Only 25%, they got 75 percentile, only 25% are faster than they are, which
Right.
means a lower score.
Right.
Yeah,
Okay.
that will make a lot more sense when we get to the normal distribution curve, because then we're gonna have like, you know, numbers up here. That's gonna make sense. If I get a score here, this is kind of being like, it represents the exact same thing on the left side of it as the right side of it. Height, is it positive to be tall? Is it positive or negative to be short? It doesn't really matter. Is it positive to have a larger time or negative to have a positive time above the median, right? We want to be faster, so we want a smaller time. Don't get too caught up on that. It's going to make sense with the data. But here, where this comes from, yeah, this says 20th percentile means she's 11th in the class. If we were going to put the lowest score to the highest score, she falls at the bottom end, which makes sense. 20th percentile, only 20% of the classes scored lower than her. So she would be ranked 39th out of her class. And this didn't ask for rank. This asked just how many people are below her. It's clear if 10 people are below her, then that many people are above her.
Right.
15, again, around the same time or same setup. Eldrick finished in the 77th percentile with 88 players. How many golfers finished above him? So here we find X, and we take 88 minus X.
Which is where we needed another rank.
Kind of in that sense. That would be true rank, right? If we set it up the same we did above, where we have X, put it this way, we have X over 88 equals 0.77. This X is how many are lower. Right. So
Lower than 88.
this X would be how many are lower than 88. Or sorry, how many are lower than our scorer, Eldrick, whatever his name is. So what did we get for X here? 0.77 times 88? 67.76?
Yeah.
76. So we round that up or down. Let's say we'll round it to 68. 68 people are lower than him. So 88 minus 68 would give us 20. So if I take 20 divided by 88, do I get 0.77? Oh wait, no, that wouldn't work. Sorry. That's something. So 20 are, so if I take 88 minus 20, 88 minus 20 divided by 88 gives me 77.2, yeah. What does the back of the book say in 15? Does it just say 20 or does it give you a decimal? It'd be weird to give you a decimal because you can't have a fifth of a person above
What is
you.
number 15? It says 19.
It says 19? Okay, so what they do is then they say, okay, you have to take in account his spot.
Okay.
So there's 19 above him
This is 20.
because he's the 20th.
So
So 19 above.
88 minus 19.
It would still be 88 minus 68 to get 20. 20
No,
above
it's
that.
just saying there's 19 above.
And so he would be the 20th spot.
I just minus 1.
You can, yeah. Yeah, that's, so if you're looking for his spot, you have to take your answer minus 1. If you're looking for how many are below him, that's just X. That's already taken into account, how many are below him. So X is how many are below him. So 88 minus 68 would give you 20. So he would be the 20th spot, so 19 people are above him. And if he's the 20th spot, then 68 people are below him, which makes sense, because there's 88 people total. 17 is like what we did with Miguel. What was his name?
Yeah.
Some other person. So it's going to be the same approach. What did I say this was to? 21?
Yes. On 21, all of them were set numbers.
Yeah, they did. So are they grouped in 20 or in the
Oh,
18,
they have
24?
more
Yeah.
space here.
Yeah. So when I print this to OneNote, it's with the tables. It doesn't register them. So yeah, this is just in your book. It says 18, 24, 19, 20. It's clear to read that. And it's 20 students. So what is the percentile rank of 33? What is the rank from the top of 33? So it's like the first person, the second one. Be careful with percentile rank and rank from the top. That's what I was talking over here. This person would be ranked first. This person would be ranked second, third, fourth, all the way down to rank 20th. So if I wanted to take the rank from the top, the ranked 5th, they could be in the 80th percentile. And so that's what you're kind of doing here. What is the percentile rank of 33? And what is the rank from the top of 33? What age corresponds to the 20th percentile? Right? So the 20th percentile, x over 20, because there's 20 people, equals 0.2. So x would be the 4 people below. So you're looking at the 5th number, right? In the list. X is how many people are below it. So you're looking at the 5th number. If I want the 20th percentile. 0 percentile, 5 percentile, 10 percentile, 15 percentile, 20th percentile. The 5th number would give you the 20th percentile. Make sense? X is how many people are below it. So we're looking at the 5th number. You have to add 1 here if we're looking for it. And if we're going the other way, we subtract 1 to get how many people are above it. Because you have to think of that person holding that spot. So 10 people are below it, 9 people are above it. This is a spot as well. So you can be off by 1 both ways. So I think we covered all those. and give you guys some time to look those over. On Friday, we do have class, even though it says online. The online class is next Friday, the 3rd. OTC is having their big 25-year celebration. There's going to be pizza, cake and ice cream, maybe even raffles for you guys to win. I'm not so sure. You're supposed to wear OTC gear, and you can win different things.
Yeah, and then if we figure out the probability of winning the round.
Maybe.
Ooh.
All right, I will see you guys on Friday.
Hey. Oh, yeah.